So here is an online sales example showing 5 different customers. This comes from a larger data set that I have, and it shows their time spent using an online support chat feature and their corresponding amount of dollars they spent. And so we have, for example, customer number 1 spent 20 minutes using the support chat feature and then went on to spend $85. And then customer number 2 spent 55 minutes using the support chat feature and then went on to spend $110, and so forth for each of these 5 customers. So we are asked here to conduct a correlation and regression analysis. So how do we do this? We want to first make sure that we do in fact have a linear relationship. And so before we do that, we need to figure out which one is our X quantitative variable and which would be our Y. So if you're not sure, you can just ask yourself, what are we interested in knowing? And we are interested in knowing either the time spent or the online sales, and most likely a company would want to know the sales. And so they would be our Y values, and then our time spent would be the X values. So the first thing you want to do is make sure we do in fact have a linear relationship. And so I have gone ahead and plotted this. I'll show you in just a moment. But if you look carefully, because we only have 5 points, we can see that as the time spent increases, so do the online sales. So we can see here we have a positive relationship between X and Y, and maybe strong. We can see, we'll take a look. There is the plot in the bottom right. We have on the x-axis the time for in minutes for those 5 customers. We have 5 data points. And then we have on the y-axis the sales. So we do in fact here have a strong linear relationship and positive. And so we can then proceed with the methods used in this course. If the relationship had not been linear, we would have to use different regression methods taught elsewhere. But here we're good to go. We can proceed. So first thing here we want to do, we want to get what is the average time spent. And if you calculate that, you should get 62 minutes. And the average amount spent in dollars, so the average sales was $107.40. We need those 2 values to calculate 3 quantities in order to get the slope and the correlation and the intercept. So all of those we need to get on the next page here. So we'll just keep going. We'll go over here. We have S, X, Y. And that is the sum of each X, subtract the average X, multiplied by each Y, subtract the average Y. And so for customer number 1, we have 20 minutes, subtract the average 62 minutes, multiply that by what they spent. They spent $85, subtract the average amount spent in dollars. So that was 107.4. Add that to customer number 2, 55 minutes, subtract the average number of minutes, multiplied by $110, subtract 107.4. I'm losing space, but you see the pattern. Keep going until you reach the 5th customer, the last customer. They spent 45 minutes, subtract 62 minutes, and multiply that by $95, subtract $107.4, and add all those up, and you should get 2326. Now we will do the next one, the sum of the squares for the x's, and this is the numerator of our variance. So it's x subtract x bar squared. Customer number 1, we can see right there, 20 subtract 62 minutes squared. Add customer number 2, we can see right here, 55 subtract 62, it's the average, squared. Continue on until the last customer, that was 45. 45 subtract 62, don't forget to square. We should get 4480. That's the sum of the squares for the x's, sum of the squares for the y's. Again, it's the numerator of the variance for the y's. And that is customer number 1. You can see right here, 85. Subtract 107.4 squared. Add that to customer number 2. You can see it's right there. 110. Subtract 107.4 squared. You see the pattern. Continue on until we get to the last customer. Last customer spent $95. Just put that in, subtract the average and square, and equals 1265.2. So now we just plug these values into our formulas for the slope and intercept and the correlation. So the slope, oops, do that, didn't mean to do that. So slope B1, sub 1, is a function of the SSXYs divided by the SSXX. And we have those readily here, already calculated. 2326 divided by 4480. We get 0.519. That is our slope. Intercept B naught is the average y's, subtract our slope B1, multiplied by our average x. So we know this one now. The average sales was $107.40. Subtract our slope, 0.519. That came from there. And our average x's we know was 62 minutes. And that ends up being 75.222. So we have our intercept, we have our slope, and we can put that together and calculate then and determine the least squares regression line. So we'll just go over here. Least squares regression line is right here. Formally, y hat equals 75.222 intercept, plus we have a positive slope that's consistent with the plot we saw. The slope is 0.519 times x. So we can use this to plug in any value of x. So not just the x's from our data, but we could plug in, say, 90 minutes and predict what a customer will spend in sales from 90 minutes on the chat feature. So using this line based on this data. And that's the whole purpose of regression. And so we can check this. Check, we want to sub in x bar, which is 62 minutes. So when we do this, this is a way to check. I'm just going to use blue here. So y bar equals 75.222 plus 0.519. Can you predict what that should be? If you calculate it, you're going to get 107.4, which equals y bar. This is a way to check that all of your calculations have been done accurately. If you don't get y bar after subbing in x bar, then you've made an error. So the point x bar, y bar lies right on the least squares regression line. And so it's a good check. We can also go ahead and we can calculate the correlation coefficient. Now you can ask yourself, what do you think it should be? Now we know that r is a number between -1 and +1, and we saw the slope there. I mean, we can see the scatter plot shows that it's a strong positive relationship. So we know it's going to be between 0 and 1 and probably close to 1. We can predict that just by looking at the scatter plot. So let's see for sure. We'll get the exact number here using this formula. Multiply that by the sum of the squares for the y's. Take the square root of that. This ends up being 2326 multiplied by 4480 multiplied by 1265.2, and we get 0.97699. So very, very close to 1. So we have a very strong linear relationship between x and y, and that is consistent with our plot.